Yes, yes. Okay. So, recap of vectors. So, what we have learned so far about the vectors, right? Vectors has two components, right? Yes, so vectors has two components. The trivial definition, we know that it has magnitudes and it has some direction, right? Whenever you write a vector, you have to write the direction, right? So let's say you are describing the velocity of something, right? So the velocity would be, let's say, if somebody is moving like this, right? So this is north, this is south, and this is west, and this is east, right? So if somebody is moving, let's say 50 kilometer per hour, so this is the speed. And if I say it is moving 50 kilometer east, so this is the velocity, right? Okay. So you already learned about the vector quantity and the scalar quantity in your 11th class, right? So I will just give a brief recap. Okay. So you can represent a vector like this, right? A hat, and this is a. So A magnitude and then A hat. Okay. So yes. So this is the unit vector. Unit vector, I mean that its magnitude would be how much? This would be 1, right? And this is the magnitude. So what is the role of this unit vector? So this represents the direction. Right. Okay, so if somebody asks you what would be the unit vector, let's say, so this, so we can calculate the unit vector if the vector is given, right? So if the vector is given, then we can calculate the unit vector by dividing the magnitude of that vector, right? And we can also say that by normalizing the vector. Okay. So with this, we can calculate the unit vector. Understood up to this point? This we have already done, right? Now yes. So now the second point is that you have the universal unit vectors, right? So before I do that, let me write what in today's class what I'll be recapping, right? So I'll be talking about the universal unit vectors, right? And then I will talk about the representation of vectors, right? And if we know about the representation of vectors, then we can describe the operations on the vectors, right? Operations on the vectors. So what are the operations on the vectors? So they are the additions of the vectors, addition of the vectors. And then you have the subtraction of the vectors, right? And then you have the multiplication of the vectors, right? So these are the operations that are defined in the vector. And then you have the resolution of the vectors. Okay. So these are the topics that we are going to learn today. Okay. Yes, so the next topic that I was going to talk about is this universal unit vectors, right? So what are the universal unit vectors? So you see that you can, let's say you have the XYZ coordinates, right? XYZ coordinate system, Cartesian coordinate system, and you divide each coordinate in some fashion. So let's say you divide this x coordinate in slices, right? So in slices of 1 units, right? So this is how you divide. You make slices of 1 unit, and then you make the slices of y like this, right? And then you divide, and oh, sorry. So let's say this one, and then you make the slices of let's say z direction, right? So you will have these each slices. So this each slices in x direction, right? So these are 1 unit slices, 1 unit, 1 unit, 1 unit, right? 1 unit. And this is each slice is in y direction. So 1 unit, 1 unit, 1 unit, 1 unit, right? And then in this direction, you have 1 unit, 1 unit, 1 unit, right? So in x direction, each unit represents I hat, right? So this is x, this is y, and this is z. Okay. So in x direction, the unit is called the I hat. In j direction, the unit is called the in the y direction, the unit is called the j hat, and in k direction, 1 unit is called the k hat. Okay. So these are called the universal unit vectors. Understood? So I, j, k, okay. I, j, k are called the universal unit vectors, right? And as the name suggests, they are unit vectors, right? And universal, by I mean that they are accepted globally, right? All the people define the vectors in this one, right? So these are accepted globally. Okay. So that is why the other people, if you move to America or if you move to other country, Europe, so they will not define like M, N, O, right? So in there, they will also define like I, J, the 1 unit in X direction, the 1 unit in J direction, the 1 unit in K direction. Okay. So I, J, K are called the universal. Unit means that the magnitude of I and the magnitude of J and the magnitude of K would be how much? So this would be 1, right? So these are, and these are in the X and Y and J direction. So I, J, and K are mutually perpendicular, right? So these are some basic properties of the universal unit vectors. Okay. And any vector you can represent in this universal unit vector. So let's say you move 3 units. you move 3 units in the x direction, right? 1, 2, 3. So what would be the position in the vector form, right? So what would be the position? So position would be 3i only, right? Let's say if you move 3 unit in the x direction and then 2 units in the y direction. So 1, 2, right? So here is the point. So this is the vector. This one is the vector, let's say r. This one, let's say this vector is, let's say m. Okay. So this m vector would be how much? So this coordinate is how much? 3 and 2, right? So the position of m vector would be how much? 3i plus 2j, right? And let's say this moves in z direction. How much distance? 4 distance, right? So let's say this is the j direction, so we have to take this. So 1, 2, 3, 4. So this much. So this direction, right? So this is, let's say, n vector. So this point would be called what? 3i plus 2j plus, let's say, 4k. Right. So this is the n vector. So this is point 3, 2, and 4. Okay. Understood up to this point. So this is how you represent a vector in universal unit vector. Understood? Okay. So now what would be the magnitude of this vector? So let's say any vector. Now you can write as axi, the x component, and then the y component, right? So this was the x component, this was the y component, this was the z component. So z component, right? So you can write any vector in this form. This is in the universal unit vector form, right? So and then the vector has 2 components, right? 2 parts, right? Vector has 2 parts. One is the what? One is the magnitude and the other one is the direction, right? So we can calculate the magnitude of this vector like this. So the magnitude will be ax square plus ay square plus az square, right? You can apply the so this would be the magnitude, this distance, and you know from the distance formula this point is 0, 0, 0. So x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this would be this. Okay, this would be the magnitude of the vector. Understood? And if the vector is in 2 dimensions, right? So if the vector is in 2 dimensions, so for 2D, this would be how much? A would be simply axi plus ayj, right? And the magnitude would be simply ax square plus ay square root under, right? So let's say I give you some vector. Let's say first question. Let's say a vector is 2i plus 3j plus 5k, right? So can you tell me what would be the magnitude here? You tell me what would be the magnitude. Okay. You calculate and tell me what would be the magnitude. Hmm. So how much magnitude did you get? What value did you get? Calculating or done? Or you are not calculating? Should I calculate? Okay, still calculating. Yes. So what would be this A magnitude, right? So this would be 2 square, AX square, right? AX is 2, and then AY is 3, right? And AZ is 5, right? So 2 square, 3 square plus 5 square, right? So this would be how much? 4 plus 9 plus 25. So this would be how much? 13 and 25, 38. Right. So this would be, if I, okay, so this would be 38, right? Right. So did you got this, did you get this value? Right. This is simple. You already, yes. So you already learned this. Okay. I'm just recapping. Okay. And then we will move on to this NEET questions. Okay. So, and then what would be the unit vector if I ask? What would be the unit vector? So your vector is given, right? And you know the magnitude. So the unit vector would be what? Vector divided by the magnitude. Right. So the unit vector would be, yes. Yes, this depend upon the answer which is provided, right? So let's say if they give the options like root 38, root 37, and let's say 6, and then let's say they give like root 48. Okay. So if these kind of question and is given, then just leave it at that. Or if they write like 6.21 or 7.43 and then etc etc, so then we have to simplify. Or if they write, so this is how much? So this is 19 into 2, so this cannot be right. So we have to find the root here. Okay. So if they ask you to simplify, you should say they have the simplified option, so then we have to simplify. Right? If they're not, so it just leave it at that. Okay. Okay. Yes. 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 So what would be the unit vector then? So the vector is 2i plus 3j plus 5k. Right. And what is the magnitude? Magnitude is root 38. Right. So this is the unit vector. Now this would be what? 2 by root 38 I hat plus 3 by root 38 j hat plus 5 by root 38 k hat. Right. So now this we have to rationalize. So this would be 2 root 38 by 38. This would be 3 root 38 by 38. And This would be 5 root 38 by 38. Right, so this would be how much? This would be so this would be how much? So this is 19, right? So this would be root 38 by 19 I had, and then 3 root 38 by 38 j hat, and then 5 root 38 by 38 k hat. So this is the unit vector. Okay. Understood. Any question up to this point? Okay. Now you have so representation is clear. Now you have addition of vectors, right? Okay, so in addition of vectors, there are two kinds of. So there are two possibilities, right? So in addition of vectors, there are two possibilities. What are the possibilities? Two possibilities. That one is that vectors are given in the universal unit vector form, right? And the second possibility is that vectors magnitude are given, right? And the angle between them is given. Angle between them is given, right? So A given, B given, and angle between A, theta is given, right? So this is called the polar form. Okay. So you have different rules for this, for the case of addition, right? So let's take the first case. In first case, this is simple. Okay, so for first case, you have, let's say, a vector, which is 2i plus 3j plus 4k. Let's say, and you have b vector, which is 3i plus 2j plus, let's say, minus 7k. Okay. So then what would be the addition of vector? A plus b would be simply 2i plus 3i, which would be 5i, and 3j plus 2j would be 5j, and 4k minus 7k would be minus 3k. Right. So addition is simple in the in the case of what? The universal unit vector form. Right. And then what would be the magnitude here? So let's say this is R. So magnitude of R would be simply what? 5 square plus 5 square plus minus 3 square. So you can write as, so this would be how much? 25 plus 9. Right, so 59. So this would be the magnitude, right? And direction you can calculate. So direction would be how much? R vector by R magnitude, right? But what about the second case? So let's say you have two vectors. Okay. So for the second case, which is the polar form. Right. So for the polar form case, we have, let's say, this vector is given, right? And this vector is given. And the angle between them is given, right? So how will we add these vectors? So what would be the resultant? So what would be the resultant? And as you already know, so there are two methods, right? There are two methods. One is the parallelogram law, right? And the other one is the triangles law, right? So parallelograms law, triangles law. So in parallelograms law, what do you do? So the vector has two parts, right? The representation of vector, the geometrical representation of vector has two parts. One is, this is called the tail of the vector, and this is the head of the vector, right? So when you place the vector v, you transport it parallelly and you place the vector b in here, right? Parallelly to this b, right? On the head of this vector. So this is vector b, right? And then you place vector a on the head of this vector, again parallelly. So you will make a what? Parallelogram, right? So this structure would be, this geometry would be a parallelogram, right? So, and when you make the diagonal from the tail of this vectors, right? From the tails of these vectors, so that is called the resultant, right? So this is the resultant, which is a plus b. Okay. Now the question arises, what would be the magnitude here? What would be the magnitude, right? So we will see that this would be simply a square magnitude plus b square plus 2ab cos theta, right? So we will see that shortly, how that comes. And in case of triangles law, what do you do is that, so this was two vectors, right? B vector and a vector, right? So what do you do is that you put the tail of this vector in here. Okay. So this is a b vector now, and when you remove this part. Okay. So now this is a vector, b vector, and this is the angle between a and b, right? So this is theta. So the line joining the tail and head of the other vector would be the resultant, right? So this would be the resultant. So this is called the triangle's law, because you see a triangle is formed. In this case, a parallelogram was forming, right? So this, so the result is the same, right? Whichever idea you apply, the result will be the same. Okay. Now let us calculate what would be the magnitude and the direction, right? So this would be the direction, the angle between the resultant and vector A. Okay. So you know that if this is the vector, right? And this is the theta, let's say this is B. So this would be how much? This would be B cos theta, right? and this would be b sine theta. Okay, right. So let us draw this diagram here. So we have this kind of diagram, right? And we have writing only the magnitude. We are writing only the magnitude, right? So this is theta. So this is b, this is theta. So perpendicular would be what? This would be b sine theta, right? And this would be how much? B cos theta, right? This part. Okay. So this part would be b cos theta. This part would be b sine theta, right? Now this is the right triangle, right? Right angle triangle. This one. Okay. So for this case of right angle triangle, R is the hypotenuse, right? So your R square would be what? The perpendicular square, which is b sine theta, right? And this base square. So this base is how much? A plus b cos theta whole square, right? So this would be how much? So this would be b square sine square theta plus a square plus b 2ab cos theta plus b square cos square theta, right? So b square is common here, right? So b square will be common, so we will have b square sine square theta plus cos square theta, only two terms which have common b square. And then we have a square, and then we have 2ab cos theta. So this would be how much? Sine square theta plus cos square theta is 1. So this is b square, a square plus 2ab cos theta. And when you rearrange this, so this would be how much? A square plus b square plus 2ab cos theta, right? So this is the, oh, I have written square here. So this would be, right? So this would be only R. So your R magnitude would be how much? A square plus b square plus 2ab cos theta, right? And what would be this angle? Alpha, right? So this is alpha, this is perpendicular, this is base, right? So what would be tan alpha here? So your, yes. So your tan alpha would be perpendicular upon base, which would be perpendicular is b sine theta upon base is what? A plus b cos theta, right? So this already you know, right? So these are the two resultant magnitude in the polar form, right? This is the magnitude, this is the direction. Okay, understood up to this point? Oh, okay, yes. Now you have what? So let's say I give you one question that let's say um, let's say you have two forces, right? So one magnitude is 2 Newton, right? And the other magnitude is what? 3 Newton, right? And they are at an angle of, let's say, 60 degree, right? So what would be the resultant F, right? What would be the resultant F? You calculate and tell me what would be the resultant. So this is a very simple question. Yes, so are you calculating? Yes. So how much did you get? F would be simply what? F1 square, F2 square plus 2 F1 F2 cos theta, right? And and this would be how much? So 2 square plus 3 square plus 2 into 3 cos 60 is what? Half. Okay, so this cancels. So we have 4 plus 9 plus what? 6, right? So this would be how much? Root 90. So did you get this value? So did you get this value? Right. And then there can be 3 special cases, right? So 3 cases of polar form. So what can be those cases? So let's say if your theta is 90 degree, right? So your vectors are A and B and they are at 90 degree, right? So then what would be the magnitude? So magnitude would be A square plus B square plus 2AB cos 90. And you know cos 90 is 0, so this cancels. So this would be simply A square plus B square, right? And what would be the angle then? Angle would be tan alpha is B sine 90 by A plus B cos 90. It again cos 90 cancels, sine 90 is 1, so this would be B by A, right? So if vectors are at 90 degree, so let's say your vector is, uh, let's say your vector is A is 2I and B is 3J, right? So resultant would be simply what? 2I plus 3J, right? So magnitude would be simply what? 2 square plus 3 square, right? So this would be how much? This would be 4 plus 9, so this would be root 30. And what would be the angle? Tan alpha would be simply, tan alpha would be B, which is Y by A, right? So 3 by 2. Right, so alpha would be tan inverse 3 by 2. So this is how you can calculate, right, the angle. Okay, and this was the first case. The second case would be what? So let's say if vectors are at the same angle, right? So this is A vector and this is the B vector, right? So theta is 0 degree. So then your magnitude would be what? Magnitude would be a square plus b square plus 2ab. And this is what? Cos 0. So cos 0 is 1. So this would be a square plus b square plus 2ab. Right. So this would be a plus b whole square and then root. So this would be a plus b simply. Right. And then when you have a plus b, which are anti-parallel, right? So anti-parallel meaning that this is a and this is b, right? So the angle between them is 180 degree. Okay. So now what would be the resultant and magnitude, right? So this would be a square plus b square plus 2ab cos what 180 degree, and 180 is what? Cos pi is -1, right? So this would be how much? A square plus b square plus 2ab -1, right? So this would be, so are you noting it down? Am I going too fast and you are not able to note down, or what? You can stop me, and then I can scroll where you have missed, and then then you can write. Okay, so please tell, are you noting it down? Then I can scroll which point you missed. Okay, so this would be a minus b simply. Okay, so are you noting it down? Okay, so did you miss anything because I was scrolling so fast? Hmm. Okay. Ah, okay, that's good. Your speed is fast. Okay. So this is these are the three special cases. Okay. Now let us do one NEET problem. I wanted to do all these recap these part, and then go into the question that I have prepared. There were so many, right? So in the next class, I will be doing these questions. Okay, so but before that, I needed to complete this theory part, just the recap of this theory part, right? So we are at subtraction. So we completed this addition, right? We will do the subtraction in a moment, but before we do that, let us uh, let us do this question, because this question we have done the concept of this question. So I guess this was in here. Okay, right. Where did it go? Huh? What happened? Yes, so copy. Hmm. Huh? Where did it? Okay. Hmm. Why is it not copying? Okay, let me cut that part and then uh, so let me try one. Finally. Yes. So you see this question in above question, we did this kind of question, right? So you can see that what is the information that is given in this question? What is the information? The crucial information. The crucial information is that it is a unit vector, right? A unit vector is represented by this, right? So let's say this is some a hat, right, which is defined like 0.5 I plus 0.8 j plus ck, right? And then they want us to calculate the value of c. Okay, so we have to find c. So what we can apply? So this is a unit vector. So what? Yes. So this green color. You meant to say this green color board or this orange color pen? Orange color pen or sorry about that. Yes. So let me write again. Sorry about that. Yes. So let's say a unit vector is given, which is 0.5 I plus 0.8 j plus ck, right? And we have to calculate the value of c, right? So what do we know about the magnitude of this a vector, right? A unit vector. So what would be the magnitude? Hmm? So if we calculate the magnitude in both sides, so this would be how much? So this is 1, right? And this would be how much? 0.5 square and then 0.8 square and then c square, right? Right, am I correct? Right, understood this point? Yes. So now you see we can square. So by squaring we can get, so this would be 0.5 square and this would be 0.8 square and this would be c square, right? So this would be how much? So this would be 0.25. This would be 0.64, right? And this would be c square. So this would be 1 minus 0.25 minus 0.64. This would be c square, right? So this would be 1 minus 549, and this would be how much? 2 and 68, right? So 0.89. So this would be c square, right? So what would be the answer then? C square would be uh, 1 minus 0.89. So how much is this? So 0.89. So 1, this is 981, right? So 0.11. So C would be root 0.1. Understood? So which would be the answer? So I need to use the different way. So this would be the answer. Understood? Understood. Any doubt up to this point? Yes. So now it is not possible to complete this subtraction of vectors, right? So we will stop it here, and in the next class, I will quickly finish this multiplication, resolution, and subtraction, and then we will do all these